Hello and welcome to the Sustainable Materials Management webinar series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Scott Marks and I am a program manager for the Recycling Market Center. I will serve as the moderator today. Today's webinar topic is biochar. We have three presenters today. First, we have Tom Miles, who is chair of the International and U.S. Biochar Initiatives, as well as Mark Highland, who is president of Organic Mechanics Soil Company. And our third speaker is Chuck Hegberg, who is who is vice president of business development at Ecotone, Inc. and owner of Infinite Solutions. We're going to have a QA session at the end of the presentation. So if you have a question or comment, use the Q&A feature at the bottom of the Zoom menu to leave the questions, and we'll compile them and then ask them at the end of the presentation. Please note that an edited version of this webinar will be made available via YouTube on the National Recycling Coalition and PA Recycling Market Center websites. Also, please note that the Pennsylvania Recycling Market Center, its affiliates and funders, and the National Recycling Coalition assume no liability resulting from the use of any information provided during the webinar. The webinar is only provided as an informational tool, and no discrimination is intended, and no endorsement by these organizations is implied. So we're just going to kick it off right here with Tom's presentation. So Tom, you are first to go.
Okay, good, thank you. And many thanks for the opportunity to present today. The U.S. Biochar Initiative is a nonprofit association of scientists, engineers, farmers, and biochar producers dedicated to the promotion and use of biochars, which are safe, stable, and sustainable. So I'll just provide a brief introduction or overview of biochar, what it is, primarily looking at resources, products, and production. And I'm using for today's example Pennsylvania as a location, but what I have to say applies to other locations around the country. So Pennsylvania, for example, has abundant organic resources that can supply nutrients and carbon to urban soils, landscaping, and green infrastructure. In organic recycling, the state diverts 860,000 tons a year of organics to compost facilities. There are more than 350 facilities for yard trimmings, 25 for food scraps, 8 for mixed organics, and 9 for biosolids, serving a population of 12.9 million people. There are animal wastes available from 27,000 farms. There are mushroom residues from 113,000 farms. And you have a real treasure in Pennsylvania in the form of Biocycle. Biocycle Magazine, Biocycle Connect has been serving the organic recycling industry for 60 years. But again, this source of nutrients is a combination of nutrients and carbon. And you also have a large quantity of wood waste, as most places do. You have oversized from composting, you have land clearing, debris, you have construction demolition. Wood products, there's 5 million tons of wood that's harvested out of a stand of 120 million. So the total combination of organic recycling and wood waste add together and can be used to provide improved soil biology, water and nutrient management, soil structure, and carbon drawdown. Also point out that the woody waste can be converted to both energy and carbon in the form of biochar. So composting generates a significant amount generally involves a significant amount of nitrogen. If biochar added to composting will capture that nitrogen, make it available to the plants. The same is true of phosphorus. So in Pennsylvania, for example, as in many other states, there are some good resources already for biochar. One of the earliest companies was Soil Reef, a company called Rhizochar, which is an inoculated char, Organic Mechanics. Mark will speak today. Green Light Plants, Dale Henderson has a lot of experience with biochar, as does Gary Gilmore, who's just recently retired from the Forest Service, and Chuck Hegberg, who will speak today. On the policy side, the Department of Conservation and Natural Resources, as I think Chuck will show, has some experience with biochar, EPA Region 2 and 3, has been supportive of biochar and water quality. You've got some great research organizations and laboratories, back labs, and even Rodale Institute and Longwood Gardens also have experience with biochar. And you've got two great technology providers for industrial scale biochar production in the form of Highland Patterson and Ecoremedy in Pittsburgh. So carbon in biochar is delivered in solid and liquid forms, provide structure and function in soil functions. And this slide is to show, to remind us that what inspired this was terra preta. In the upper left-hand picture, you can see us in Brazil about 10 years ago looking at the terra preta soils. And just a reminder that the biochar, even though it's charcoal, will wind up in a soil solution. So you have a combination, as was with the terra preta, you have a combination of nutrients from, in their case, from kitchen waste and biosolids mixing with charcoal together in the clay and making a soil solution. So biochar is available in chip form, as you see there, also in a finer, that's a 1/4-inch grid, kind of a sawdusty form. It can be combined with fiber, densified, granulated, or even available in liquid form. And it's really the physical, chemical, and biological properties of biochar that really make them versatile. When wood or biomass is heated, a skeleton of carbon is left as fine-grained, highly porous charcoals that help soils retain nutrients and water. Their physical, chemical, and biological properties make biochars versatile environmental materials. Carbonized wood can be highly porous, with pore sizes and surface areas that are suitable for capturing gases and nutrients essential to plant growth. The porosity improves water infiltration and water retention, helps soils to make more water available to plants, which extends the growing season. This is what makes biochars like batteries, which store energy and nutrients for the microbiome to cycle nutrients, carbon, and energy through the plants and soil. Ash and carbon in components of biochars vary, which enables them to improve growth. These properties also enable biochar to capture pollutants in stormwater. Their large specific surface area, porous structure, and the content of nanocarbon organic fractions provide high variability in surface functional groups, which enable sorption of pollutants and nutrients. Biochar products are suited to urban uses like garden landscape, turf, horticulture, and community gardens. New products and management techniques include biochars, biochars with compost, biochar-based compound fertilizers, biotic soil amendments where biochars are combined with organics, minerals, and biologicals, granulated and liquid products for seeding, and even micro and nanocarbons. Urban soils are notoriously bad. Biochar-based products are useful amendments. Biochar suppliers are learning to provide biochars of consistent qualities to soil blenders and formulators. Environmental markets include the use of biochars to clean air and soil, clean water, cool heat islands, conserve water, and sequester carbon. They can absorb odor and pollutants. Biochars are used to filter water and reduce organic pollutants. Innovative uses of biochar in urban forestry include improving tree survival at establishment, soil decompaction, growing media, and revegetation. Non-soil carbon products and markets are emerging such as feed and building products. Arborists use biochars in their growing media to establish or repair urban trees. Biochars are used in structured soils, rain gardens, and bioswales to improve growing conditions and reduce pollutants. The city of Stockholm, as Chuck will describe, uses biochar and rock in structured soils to reduce tree loss from compaction. Excess heat from carbonization is used to heat buildings. This practice has been duplicated in other Scandinavian cities. These biochars are also used in green roofs and other green infrastructure. Biochars are added to fiber, seed, and fertilizer to improve plant establishment and hydroseeding. They're increasingly used in bioswales and rain gardens to prevent metals such as copper, zinc, and cadmium from entering waterways. City of Minneapolis uses biochar to filter E. coli and stormwater. Biochars are used to reduce chemical oxygen demand. The benefits and appropriate use of biochars in these applications has been demonstrated thoroughly in science and practice. Biochars are effective tools, but more landscape architects and engineers in public agencies must write specifications and approve biochar-based products for demand to grow. New uses in building materials such as wallboard and cement increase the potential to sequester carbon with biochar. Biochars in wallboard provide additional cooling and reduce the electromagnetic transmission from house wiring. Biochars improve cement properties and reduce the weight of masonry and building materials. These products are still in testing and development. Biochar improves properties of plastic composites for landscape, building, and decorative uses. At least one company is nearing commercial production. New biochar products have been developed for improving the resilience of asphalt, for stabilizing road beds, in building blocks, and to reduce the weight in masonry. Mobile and stationary systems are used to produce biochars. Systems with capacities up to 2 tons per hour are usually mobile or modular. Production rates of 2 to 6 tons per hour are typically done with existing pyrolysis or gasification technology. Biochar is made by heating wood in the absence of air. In this simple kiln, a high-quality biochar can be made by limiting air at the base of the fire. Wood is heated as it sits in a pool of pyrolysis gas. As the wood is heated, gases evolve, which mix with air above the rim and burn above the kiln. Radiant heat from the flames heats the wood and converts it to oils, gas, and char. Biochar can be made in small engineered kilns or controlled piles, which are usually less than 1 cubic yard. Mobile carbonizers can process urban wood from land clearing, prunings, and old pallets at capacities of up to 200 dry tons per day, producing about 3 to 4 tons of biochar. There are about 30 of these systems in operation. They're mostly used for residues with tipping fees such as urban land clearing and orchard removal. These chars can be used directly or modified for value-added products. The U.S. Forest Service has been developing a small mobile carbonizer in cooperation with Air Burners, Inc. The mobile air curtain burner has been in use since the 1990s as a clean alternative to burning slash piles. The burner under development removes biochar as it is formed. The machine is intended to have higher carbon recovery than existing mobile carbonizers. The U.S. Biochar Initiative will assist field testing the prototype in 2020. Scale up to larger capacities will be determined by the commercial partner. Some existing biomass energy facilities recover fly ash with high carbon content. While most plants are designed to re-inject and re-burn fly ash, some plants can recover it for use as biochar. This 30 megawatt plant consumes about 240,000 tons of wood waste per year and can produce about 10 cubic yards of biochar per hour, or about 72,000 cubic yards, equal to 9,000 dry tons per year. The chars are often post-processed to remove fines depending on the market. Small-scale gasifiers and boilers can generate heat and biochar. The units shown consume 500 to 600 pounds of fuel to produce 2 to 4 million BTUs of heat and 100 to 150 pounds or half a cubic yard of biochar per hour. They'll produce about 500 tons or 4,000 cubic yards of biochar in a year. This 2-acre greenhouse converts wood to heat, power, and biochar. Fuel is delivered to the greenhouse. A self-unloading trailer meters the fuel to a gasifier, which converts the fuel to gas and char. Part of the gas is fed to a generator. The rest goes to a boiler, which provides heat for the greenhouse. The biochar is retrieved by the fuel supplier, who uses it to enhance food waste compost. This modular system can process 1.5 tons per hour to produce up to 10 tons of biochar per day, or 24,000 cubic yards, or about 3,000 tons per year. Stationary pyrolysis provides additional process control for value-added products. And finally, mineral-modified biochars mimic the man-made or anthropogenic soils in the Amazons, like the terra preta we saw earlier. Minerals like magnetite or expanding clays like bentonite are added to wood during carbonization. The intermediate biochar is then baked with additional minerals in a secondary process. The results are mineral-modified biochars, which have several times the value of biochar and can be used both in soil amendment applications and also in stormwater applications. So in summary, Pennsylvania, for example, has abundant organic resources to make biochars for use in urban soils and green infrastructure. There's knowledge and support for biochar in industry, academia, and government. Locally, biochars can be made in small, medium, and large industrial quantities, and raw and engineered biochars are suited to improve soil and water quality for use in soil amendments and in green infrastructure. And thank you very much.
All right, thank you, Tom. Next to speak is Mark Highland. Go ahead, Mark.
Hello, everyone. Thanks again for the invite. Happy to come and talk about biochar today. About biochar. Here we have Love Park in Philadelphia, and then we also have 30th Street Station in Philadelphia, both of which have engineered soils that contain biochar in them. So this urban soils, starting organic mechanics, I have a very unique perspective on it, but certainly we've done a lot of work with landscape architects, landscape contractors, various city agencies to provide biochar for projects, specs, et cetera. So this is, my perspective on biochar use in the soils. So, we were going to add soil amendments because they improve root zone conditions. Most of the time we are talking urban poor soils for construction projects, et cetera. And so we want to do all these things when we add soil amendments, right? You're trying to build soil structure, build organic matter when it's lacking, improved conditions. It's going to store more water, more nutrients, feed the microbes and filter stormwater, all functions of soil, but we want to enhance the soil to build soil structure so that the soil can perform better for us in our landscapes. Can biochar solve all landscape problems? No, of course not. No, it's not a silver bullet, but certainly it is a tool in the tool chest to use. And certainly any time you're looking at a project, I always encourage a soils management plan so that you only till once after you know exactly what you need, or air spade. Definitely post-installation, you need a nutrient management plan. You need to monitor things to make sure that things aren't going sideways at the site because certainly as long as you do your due diligence up front, it's not going to be the biochar causing problems. It's going to be one of these other things. Of course, biochar is very helpful in soil. It can do a lot of benefits. So, some of these things can be mitigated through the use of biochar. And Tom gave us a great overview, some pros and cons of biochar in relation to using it in urban soils or for an engineered soil. It's going to increase your water and nutrient holding capacity as well as that biological content. It is somewhat permanent, as Tom alluded to, the terra preta soils that carbon is still in the soil. There is some mobile matter, there is stuff that's going to be around a long time when we add biochar. So there is a good portion of it that is relatively permanent, certainly in terms of human lifetime. Shown to be great at increasing permeability, breaking up compacted soil. Of course, you're sequestering CO2. It does add buffering capacity, although pH can be alkaline. Right now, source quality will vary. Bulk shipments are generally the norm. And for use in landscape, will require pre-inoculation for best results. There's a number of ways to inoculate, but regardless, and we'll talk a little bit more about that in a second, high quality biochar can be expensive. There's a lot of biochar out there, and you need to make sure you're getting a quality biochar for the application, right? There's lots of different applications. It doesn't always have to be the highest quality biochar. Sometimes it can be a slightly lower carbon content biochar. You're still getting benefit from it. So again, it's project specific. Just a quick application rate, if you're putting a 1/2-inch layer, right, you need at least 1.5 cubic yards to treat 1,000 square feet. In sourcing biochar, certainly the source material can be important, wood versus manure. I'm sure Chuck will maybe touch on this as well, but wood-based biochars are generally proven for stormwater management. The manure-based biochars are going to have a bit more fertilizer in them, so we don't want to use that in a stormwater situation where you're trying to keep the fertilizer out of the water, so the wood-based biochars can be better for that. Some ideal properties, ideally pH between 7 and 8. You don't really want a pH of 10 or 11 with your biochar because the ash wasn't removed. So a high pH can affect things. You just need to know what it is. Carbon content needs to be above 60%, according to the American Association of Plant Food Control Officials, in order to call it biochar. And I know that there is some internal work and debate on that number, but right now that is the rule. So it needs to be above 60, and I'd like to see it up closer to 80, because again, the carbon content is directly related to the biochar. Ash content is going to be nutrients. There's nothing wrong with nutrients. Plants need nutrients, but you just need to know what you're getting. Low residual hydrocarbons so that there's less for the microbes to break down before plants start growing in it. And again, inoculated or not, biological inoculations versus just fertilizer inoculations. Tom mentioned there's a lot of different products that are being made with biochar, but certainly it needs to be inoculated to go into soil. As Tom alluded to, it's kind of like a battery. If you don't charge it up with something, it's going to steal nutrients from the soil and the good, and that's going to be a fail. So it does need to be inoculated. And there's lots of different ways to do that. Some of the most common is mixing with compost, mixing with fertilizers. So you do need to inoculate, right? So microbial inoculation is great. This will happen naturally in the soil if you have time. There's also research that shows if you mix biochar directly into soil, the same soil solution will form over time, the complexing that goes on between the biochar, the microbes, and the soil particles, especially in a stormwater project where you're putting in raw biochar, not inoculated, it will complex over time as well. Research shows that. Speaking of research, it's all about reducing leaching, holding nutrients in the soil. That's one of biochar's big secret weapons. So they're still researching optimum field application rates for large-scale farming trials, but certainly there is evidence that it increases infiltration rates up to 57%. Most research shows the effective rate is right around 5%. In some cases, in some plant types, it might be a little less. It can go all the way up to 10%, again, depending on project, situation, plant type, soil type, all those variables. And then the picture in the bottom right, just for scale, that's a quarter. And those are turnips. And at one of the only biochar international conferences I went to, those were brought, those were sweet, they were not bitter. Those are turnips grown in biochar. So, I mean, grows big plants. Some research showing the effects of biochar on plant growth. The first 4 that are listed are just articles. The last one is, the biochar edited by Johannes Lehmann and Stephen Joseph. This book is the real deal and gives you a lot of research about biochar. The images that you're looking at are images of plants grown with or without a biochar enhanced product. That's biochar enhanced with minerals and biology. Yeah, it's one of the products we have at Organic Mechanics. So just showing kind of the density and how the roots grow into this, and it holds together like a little candy bar when you pull out the plants at the end of the season. But just, there's a lot of research out there. There's so much. So if you're not finding it, that book, Biochar for Environmental Management, Science, Technology, and Implementation, is a great place to start. So biochar for scale, again, it's variable. You need to know what particle size you're getting because those can influence properties. That's the biochar that we get. It's typical particle size distribution. We ship it out in super stacks to be used on site for construction jobs. Here's a couple examples of some of the jobs that we have done. So the KATHRINE DULIN Folger Rose Garden, that is down in DC outside of the Smithsonian. We work with the biochar at this site to assist with all those things we reviewed on the first slide as to why we had soil amendments to build soil structure, hold water, nutrients, beneficial biology, et cetera. And so the picture on the right, that's a sculpture. It's called Split Rocker. It was done by Jeff Koons, the artist. That was in 30 Rockefeller Center in New York in 2014, summer. But the permanent one lives at Glenstone Foundation in Potomac, Maryland. The Glenstone Foundation, and it lives there permanently, and that one also has biochar in the mix. That was a soil that we designed working with the entire team at Glenstone. But a couple projects where biochar went in and is really enhancing the lifetime of the soil. So this particular structure, this split rocker, it was installed at the Glenstone Foundation 7 years ago. They asked for the soil to last at least 7 years without any change outs. And if you think about how would potting soil last 7 years with no change outs, this is a very custom blend that biochar is a permanent part of it. There's a lot of mineral elements, inorganic elements that went into it so that it can last that long in between changes. But we all attribute a good bit of the health of the structure, the long-term health of these plants, to the biochar being in the mix. So, it's a summary slide, picture on the right. We also provide biochar to the Rain Check program in the city of Philadelphia. The Philly Water Department has partnered with the Pennsylvania Horticulture Society to Rain Check program, where residents can get a downspout planter and all the soil that comes with it, which is engineered stormwater soil. But again, working with the engineers, working with the water department, have convinced them that biochar is a very valuable addition and absolutely should be in these stormwater planters. So that's the picture on the right. But I can't agree more. It will modify physical, chemical, and biological properties of soil over time. Certainly research shows has the greatest effect on poor soils. If you're in the Pacific Northwest and your soil is just dark, loamy, gorgeous soil, biochar isn't going to have the extreme effect as it would if you're in a sandy soil or a high clay content soil. That's where plant soil benefit, and they're not all created equal, and you need to be asking for test results. And if you're a producer supplier, you need to be providing those test results, showing your customers what your biochar is made of. And there are very specific labs to be doing biochar testing here in the States. You know, it is going to increase water retention. It increases drainage. It is a permanent addition to soil. So we offer it in these engineered mixes. We also offer it in the consumer size bag, which has been doing somewhat well. Thank goodness for that. And yeah, so that's my email address. Anybody ever wants to send me a little note. And with that, that is my presentation. I know we're taking questions at the end, so I'm going to hand it over to Chuck.
Let me put this into run mode here. All right. Well, thanks, Mark and Tom. The presentation that I'm going to cover here is going to have some of the science and research in it, but for the most part is going to kind of give a run around the country in the Mid-Atlantic as far as the various types of green infrastructure projects happening that are using biochar. It's been growing relatively fast in the last couple of years. It was a pretty slow start, I would have to say, back in 2010. We are actively involved in the Chesapeake Bay TMDL program. I know a number of areas in the country are dealing with their MS4s, and we're using biochar more and more to help with that process. So just a couple of things just to kind of talk about the biochar opportunities, some of the challenges, and I'm going to touch on engineered media. A lot of folks work with that as far as the green infrastructure, and then some more recent work going on urban soil repair and restoration happening for impervious disconnect and runoff reduction. So Tom and went over this pretty quick, heavily already, so I'm not going to spend a lot of time in it, but just recognize, and of course this doesn't include the timber waste that Tom brought up, but just because you can make biochar from it doesn't mean you necessarily should, or if you do, to use it as a waste reduction method, have an outlet for it and understand what your product is going to be. Mark mentioned manure. I don't really touch on manure in this presentation. Manures are good for heavy metal removals and maybe some brownfield remediation work, but for stormwater, generally we work with a good wood waste that's clean. You can use potentially unpainted wood once it goes through, or even painted wood in some cases once it goes through the gasifier. But if you have a waste, just recognize what you intend to use it for. Now, as far as some of the challenges, as we can see, I mean, we got the climate change happening more. As far as the hydrologic cycle, the nutrient cycle, the carbon cycle, you know, we have to recognize how biochar or carbon is a critical element in having any of those cycles work and function and balance. The hydrologic cycle through soil modification, the nutrient cycle through microbe translocating or absorbing or modifying as far as nitrogen and phosphorus, and even some of the metals and stuff. Carbon cycle has a play in all that, and we need to try to get more carbon back into our soils. So green infrastructure, I mean, it's not new. I mean, it's been around for a while in different forms. I mean, the ancient Romans Empire was doing it with rainwater harvesting and flood mitigation, underground storage, flood mitigation and wastewater removal through the post-Roman era to the 1800s. And then now in the 19th century to present, there's all forms, a lot of different forms of what we would define as green infrastructure, you know, the best management practice, low impact development. Sponge cities in China is a big deal. So really it's just a matter of managing stormwater runoff using natural ecosystems or engineered systems that mimic natural systems. And that's probably one of the harder areas to work in, is trying to mimic nature and using natural products and doing it. And so one of the problems with typical bioretention media or engineered media is if you work with it, a lot of times it's made up of a tremendous amount of sand for filtering, but it really doesn't provide a lot of area benefits as it relates to water quality. I mean, you might be able to suspend solids or bacteria, some phosphorus removal, but for the most part, nitrogen removal it doesn't occur. It is prone to clogging. I mean, a lot of times you don't think about sand that way, but as it begins to settle down, just like in a beach sand, even construction sand will eventually start to plug and compact down. And so your infiltration rates will begin to reduce. But also one of the aspects that with media, engineered media, is the poor vegetative support. Because it's designed to drain quickly and infiltrate, it doesn't retain the water for vegetation, which vegetation play a role in nutrient uptake and removal and habitat, as well as soil aggregation, beginning to build those components of soils with the microbes. So what was happening was a lot of failures, particularly in the Mid-Atlantic. Let's just say many miles of bioretention swales along highways were not working because they were predominantly sand. And so there's been a lot of work in modifying that. So some of the benefits of biochar and stormwater management is, as Tom and Mark pointed out already, is a large pore volume. It has the increased water retention, very good capture of the first flush of runoff. And then through KSAT modifications, you can improve the infiltration of even the higher flows, depending on the soil you're working with. High CEC and surface area, absorb nitrogen compounds and reduce effluent concentrations. And I'll touch on a few of these in the presentation. So not to get into a whole bunch of research, as this has kind of been going on since I would say 2010 at the University of Delaware. So it's a many different types of studies, and most of it is actually being funded by the transportation industry. But with the bioretention media, enhanced media, what we have found is that we're able to retain 11 to 27% more stormwater, predominantly in the pore spaces of the biochar, and it is plant available, which is critical. In that pore space, we're getting a higher redox, so conversion potential within the biochar. And even though you're holding more water, infiltration capacities did actually increase. And I might touch on this a little bit as I get deeper into the presentation on why that is. Also, as I pointed out, we're seeing less clogging. A lot of that has to do with the fact that biochar is an irregular material just due to the shredding of the material. It's not like a rounded, material like sand or gravel. So when it goes in, you can kind of think about it as like an aggregate going into the soil, and therefore making it more difficult for soils to compact, but also to allow for more micro pore spaces to form within the soil structure. We have seen nitrogen removal from 6 to 55% on all the storms, and the nitrate removal varies significantly due to seasonality, but even that over the control was 60 to 370% increase. Some of the studies that were being done recently has been looking at different state bioretention mixes. So we have been comparing North Carolina mix to, say, DelDOT mix, which was actually requested by DelDOT. And they use a compost in their mix. And the critical component you can see in the graph below is that the North Carolina mix, which doesn't use compost, it uses wood shavings, actually did not, had a very good nitrogen removal, whereas the DelDOT mix, which uses compost, actually were leaching nitrogen and not having the removal rates. And that was the same with the phosphorus as well. So if you're trying to get nutrient removal and binding it up, adding the compost, which actually helps plant material survive, is important, or you can change your mix and add a biochar to it instead. So here's a project. This is one of the early ones. Sadly, I still don't have photos of it with plants in it. But this was done back in 2014, one of the first projects done by the Inland Bays, which was a nonprofit. And they tried a variety of different mixes in the bioretention mix, anywhere from 5% to high as 15% by volume into the bed mix. And in all cases, they're all still working well. The sad part is, and it's something that's difficult with grants and other, just in clients in general, is the funding's not normally there for monitoring. And so it's very difficult when these projects get put in to actually get any post data on them. And so it's something I think as an industry we need to get better at. This one was a project down in DC. It was actually a regenerative stormwater conveyance system. I don't know how many folks are familiar with that technique outside of culverts. If you ever looked at a number of culverts, they generally have significant erosion, and the ability to capture, reduce the sediments, but also capture the nutrients are being designed through these regenerative stormwater systems. And then this case, back in 2013, biochar was added to the mix to capture the nutrients and predominantly metals. And here's a newer one. In fact, Gary might even be on this webinar, but Gary did a great project on the governor residence for a rain garden. He was the one that encouraged it to happen. He was the creator and producer of the biochar, and he probably worked well in helping to install it at the same time. So there was one right outside the door of the governor, and hopefully Pennsylvania will take some initiative and start applying biochar on a broader scale, because it's been very successful. Tom had mentioned the concept of the structural soils. Now, the structural soil was actually developed by Cornell University, and they were using peat and a variety of other mixes. But in this case, Stockholm just basically used rock and biochar. Little bit of compost, not a lot, but primarily at the top end of the soil matrix. But really, it just stores a lot of water, and the biochar helps process the nutrients. And this is a very good technique to use in urban centers, particularly in those right-of-ways from the curb to backside of sidewalks. Anytime, you know, some downtown revitalization is happening, it's a good space to build it under the ground and put the pavement right on top, some pervious pavement, and increase the storage. And this has been extremely successful. Hard to believe that a big box of rocks can actually perform this well, but with the biochar, it's been extremely successful. And I'm hoping to try some of this on a few projects here in the Mid-Atlantic. Going a little further west here is a green roof product that was done with the Nebraska Forest Service. It was actually shredded tires as well as the biochar. This has been in since, I believe, 2017. And a lot of research going on in green roof material. The benefit is the bulk density of biochar is extremely low, and when you add the fact that you can get upwards to 30% water holding capacity, the volume and economics of a green roof material becomes more beneficial. The other benefit is that you can increase the depth of your media, which will allow you to change your plant types. So rather than going with succulents, in most cases in a shallow green roof product, you can go much deeper and get pollinators, perennials, native grasses, and even shrubbery on the roof with the benefit of the biochar without adding a tremendous amount of additional weight. So this is actually a pretty exciting space in our urban environments, and one I hope to see more of in the future. This here is basically a denitrification bioreactor. It's commonly used in agricultural areas, but is now actually being looked at also for ditch modification. That area where, you know, a lot of times people ignore the ditches along highways and so on. But those are the ones that capture the first flush of all of our pollutants, whether it's you know, the heavy metals or hydrocarbons or even the nutrients. And so retrofitting the ditches have a tremendous potential, and a combination mix of wood chips and biochar is a good way to start. You can also add other types of amendments to the mix if you want to remove, phosphorus or other components, which I can't really get into on that front, but it's a very flexible system, and one that I believe is getting looked at more and more in the process of doing the retrofits. One of the larger biochar projects was actually a stream restoration project, and in this case, it was amending the floodplain with biochar. They had a very thin layer of topsoil, and in order to get vegetation growing, they applied the biochar to the floodplain. But also this floodplain, but besides the nutrients, there were some heavy metal contaminant issues, and so it was added on as part of the floodplain and overflow treatment areas in this stream restoration. And so actually there are more projects coming out with biochar in it for banks, and even in the bed itself for increased denitrification in the hyporheic zone of some of the stream channels. This project was just done actually about 3 weeks ago. It was the wetland was not meeting agency requirements on plants diversity. And so they decided to go in, rather than using the traditional hydroseeding or hydromulching, they decided to try overseeding using biochar powder. And as you can see, there's plenty of vegetation there, but it wasn't meeting the specs. So they decided to spray it with the biochar, and it's more or less a experimental test to see if enhancement could be done to some wetlands with minimal impact. But you can also just use hydromulching or with TAC. There's commercial products available, and it helps the seed germinate faster and provide the nutrients with the seed mix along with the carbon. So you can reduce the amount of watering you need in order to get your turf established and so your slope stabilized. So it's something that could be considered. Now, an area that on this urban soils, that's kind of the area where I've been focusing in on probably since 2012 with some of the research. And a lot of it is that, you know, either turf modifications, in our case, turf to meadow conversions or wildflower conversions, but also just in urban areas, as much as we'd like to think it's great for us as maybe practitioners, homeowners generally do push back on the concept of giving up their turf, putting in rain gardens and things like that in their yards. Some of them are small yards, so they can't give up a lot of space from their perspective. So we've been studying how you can improve the soils, improve the infiltration, and get soil redevelopment occurring in the turf spaces. On this project, we actually have a 3-acre parking lot above. It's just sheet flow parking lot and goes right into a stream. And we took this turf area, amended it down. We actually broke up the hard pan down to 2 feet. And then we amended it with biochar and have recently sprayed it and tacked it with a wildflower meadow mix. Of course, just as soon as I do that, we get like no rain. But we're hoping it still moves forward. And but this site is one of the few, thanks to Pennsylvania Growing Greener, that is allowing us to really monitor this site. We got soil moisture probes, we got temperature probes in the soil, full-blown rain gauge, we got groundwater wells in, stream flow. It's just a lot of data we're collecting on this. And we're working in partnership with the University of Delaware to evaluate this site as it moves forward. Here's one that was done about 2 weeks ago. One of the biggest users right now in the region of biochar activity, at least, and even in the research, has been DelDOT and Maryland Department of, or actually Maryland Transportation Authority, which is the toll authority. The image here you see in the upper left is right at a toll plaza, And then the lower left is the recent tilling and amending of the soil. And in this case, what we're doing is just really putting a 6 to 8 to 10 foot buffer strip right off the edge of pavement, either behind the guardrail or right up against the pavement, depending on where we are. This is a rather dangerous area, so we had to work behind the barrier. But you know, we're basically tilling in using a special tiller to get deep down in the soil and amending the biochar into that space. And DelDOT is continuing to improve and expand on some of these projects, as well as in some of their infiltration basins. And so what I wanted to do real quickly is just touch base on some of that research and what's happening. So this was the first project done for DelDOT under a grant with the Chesapeake Bay program. And as you can see from the, I don't know if I can point here, as you can see here, in this study, you know, this is just a compacted soil that we have on the highway side, which is, as most of you who've worked on highways know, it's pretty dense and a mix of all kinds of stuff. But in this particular study, we were focusing primarily on the 12 inches, the top 12 inches of amendment. And when we basically, as I mentioned, the irregular biochar particles acting as sort of an aggregate. And then you have the micropores and the macropores, where we have the water holding capacity and the biology here, which helps then soil aggregation. And this is what our soil looked like. And then of course, after we modified the soil, you can sort of start seeing the aggregates more, and you start seeing a little bit of more bonding of the material. So for this study, we focused very heavily on this top portion of it. The next area that we're working on is to try to get more of the deeper infiltration capacity within the soils. So this is the only science side of it I'll show, but based on that small study, you can see that just tilling the soil, you were able to get about a 20% reduction in runoff. But by adding the biochar, we were able to get 53%. When you look at the exceedance probability curve of volume of runoff, for the most part, we were capturing 100% of 85% of the storms coming through. You can see that here the runoff, but right at this point, we're out here before we even start getting any runoff from the storms. And so we were getting approximately an 88% reduced runoff volume under this one study. Now we're basically monitoring some of the other areas that are being installed to see if that's pretty consistent. But in general, we're getting 8-to-1 ratios of pervious to impervious ratios on what we end up having to do on a footprint, which is huge when you're working along highways, because the shoulders are pretty limited on what you can do. And what's nice about it is that the DOTs already own that real estate, so they don't have to acquire more. So as far as the deep side, that deeper area, we're now beginning to experiment with the deep soil compaction, basic pneumatic technology, and injecting amendments into the soil, breaking up the compaction, and then treating the soil up on the surface area. So we're basically filtering the water, and then on any gravity flow through on infiltration, it'll go down into these fractures at a deeper pace. So depending on utilities and other constraints, groundwater, whatever, we will basically be looking at 3, 4, and 6 foot depths. In fact, we're getting ready probably in early September to trial this on a infiltration basin that DelDOT has that is currently failing. And we're gonna fracture at both a 6 and 3 foot base with a mixture of biochar and other amendments to see if it can improve the infiltration of that basin. And so with that, that's all I have for now. So I turn it back over to the moderator.
All right, thank you, Chet. I do appreciate all the speakers' time and the attendees' time as well. I know I learned a lot just listening to you guys. We do have some questions here. So actually the first question that I want to ask is more of an administrative one. So Mark, you referenced a book in your presentation. So if you had that on one of your slides, if you could go ahead and bring your presentation back up and share that particular slide so that people can see what that book title was.
You bet.
Okay, and what I'm going to do here is I'm actually going to open the floor to all three of you and just run through the questions, and whoever feels like tackling it, go for it. So we do have a couple of questions pertaining to costs. So is it available for someone to go and purchase, X amount of cubic yards of the material, and generally what does that cost? And then the other cost related question might be, what are the costs if you want to produce it yourself? Is there a market value for it? Is there a profit to be made in producing biochar? And there you go. There's the books book listed there.
So I'll let Chuck and Mark talk about the cost of purchase material. But in terms of production, small scale production is pretty expensive. We have about 135 suppliers of biochar across the United States. And what we found is that we have a large number of small producers that are delivering pretty much locally to niche markets. And then we have a few large producers that produce large volumes. But depending on the quality, we've got a real need for biochar suppliers in the Northeast. A lot of the biochar comes from the West or from the Southeast. And so you get a mix of qualities. And I think Chuck or Mark, if you guys want to talk about what's available and what cost might be.
Sure. Yeah, so we don't make biochar at our facility. We buy it in by the tractor trailer load. We had an intern try to make biochar a lot of different ways one summer, but the bottom line is you really need to scale up and buy one of the big units if you're going to be doing it. And you're going to, at least that's what I decided. So we're buying tractor trailers at a time. It's true, there definitely is a place for a top quality biochar supplier in the Northeast. We buy from a couple different manufacturers. The cost, so for example, if you were to call Organic Mechanics and order between 1 or 20 pallets of biochar, 2 yards of biochar is going to run you right around $700 for a 2-yard super sack, so around $350 a yard, and that's wholesale what we would offer it as. The more you buy in bulk, the cheaper it becomes. And there certainly seems like there's plenty of supply. But I also know that, we have gotten calls over the years from people who say they're going to start the biggest biochar facility that anyone's ever seen. And to date, none of them have really come through. But, so there is an opportunity up here, that's for sure. Chuck, do you want to comment on that as well?
Yeah, as far as supply, like everyone says, there's really not much here in the Northeast. And also, again, depending on what you're using it for, I'm kind of looking for specific type of biochar related to the green infrastructure and the soil repair work. Most of what I do is turnkey. A lot of folks really don't know how to handle the biochar and so on, how to install it, particularly dealing with government or DOTs. And so I usually just work under a turnkey on some of it. I have sold biochar. It varies as to time of year it has to be shipped in. So I'm usually around the 200 or less, depending on what it is. Mark has got some different numbers based on the type of work he's doing. So it really is a broad scale as to the biochar and the volumes that we're dealing with. Anytime you're dealing with green infrastructure, they're generally larger projects. I just did a large wetland over in the inland bays, and it took 60 yards on it. And then there was another one that we did that was over 200 yards. Now, keep in mind, when you're dealing with soils or bioretention mixes, you're only doing a percent. So most research goes by mass, so about 4% by mass, but it can go, that would be, 10%, 12% by volume. So it just depends on the soils you're dealing with and what your bioretention mix might be. But the issue a lot with the green infrastructure is getting regulatory buy-in. It's kind of interesting why it's so difficult to get it approved, especially seeing it's carbon. And it has the ability to enhance the green infrastructure. So I think the language around here is performance enhanced devices, and trying to squeeze more out of these engineered systems and or even repair some of these urban soils that we're dealing with. So anyway, that's what I got for now.
All right, thanks, Chuck. And that's a little bit of a segue to the next question. So what do you think is the largest bottleneck for widespread use of biochar? Is it education of consumers? Is it, as you alluded to, regulatory hurdles, or is it more of a supply problem?
Yeah, all of the above.
The chicken and the egg. I've been in the working in the Chesapeake Bay since 1987. And what I've learned from that process is within the environmental space, and stormwater, MS4 and all are part of the environmental space for water quality, is regulatory drives the market. There was a time no one did stream restoration, but when regulatory agencies started requesting stream restoration, then everybody started doing stream restoration, right? So the need to educate the regulatory agencies to the benefits of biochar is critical. The willingness of the regulatory agencies to allow for innovation and to try new things and not always have to follow the book, particularly here in the Chesapeake Bay and other regions, to say, well, how do I get credit for that? That's what the client's always saying, is how do I get credit for that? And so we need some more flexibility, and we need the assistance of the regulatory agencies to allow for this type of innovation to happen. And then once there's a demand, there will be producers. There's too much CapEx that goes into this equipment without having some assurance that the regulatory environment is there and the product can be sold. No one's going to put their coin down to develop a plant unless there's opportunity. So the market will come in and help, but we need a little assistance by the regulatory community.
Well, and demonstrations help. I think an example of that is Minnesota has had really good results with controlling E. coli using biochar in stormwater filtration, and we had a welcome invitation just recently from the Minnesota Department of Transportation to help them write some draft language in their revision of their stormwater manual so that we could get biochar in the book, so to speak, so that then whatever language could be modified later, but really just getting a place in the book with the understanding that by the time some regulatory language is approved, it's going to be a couple of years before an engineer can point to that passage in the text and specify a project, and a contractor can buy the biochar and put it in place. So this process takes time.
Okay, we've got lots of great questions. Thank you, attendees. We're getting some good questions in the queue here. I'm gonna combine a couple of related questions here. So the first question is, you had mentioned that creating biochar from painted wood, and that leads to the question, are there air regulations? I mean, are there specific emissions that might occur from the paint? And more generally, are there air regulations designed for these pyrolysis systems? So that's kind of one aspect of it. And then the second aspect is, talking about residual hydrocarbons in the biochar, are there any risks as far as those residual hydrocarbons in terms of handling, worker protections, leaching, anything like that?
Yeah, a couple of things. I'll take on the air emissions. Basically, anything, any device, any thermal conversion device, and that's what I do for a living, is design biomass thermal systems, whether it's combustion, gasification, or pyrolysis, and they're all regulated, and they're all regulated at the federal level and also at the state level. And so the only devices that are not regulated are the very small 1 cubic yard units that you might use in a small pile out in the woods. Once a fire is enclosed, now it comes under basically state and federal regulation. And states treat these very, very differently. But in most cases, even the mobile devices, the large system I showed that is on tracks and a mobile burner and so on, those all have to be permitted. And there's what they call a Title V permit. If you enclose something and you're converting more than 2 tons per day, then under federal regulation, you need what's called the Title V permit, which is a fairly complicated permit. Here in Oregon, they actually do health impact modeling. So they determine how far away you have to be from a dwelling if you use one of these devices, depending on what you're burning or what you're pyrolyzing. Painted wood is not acceptable. Painted wood is separated in the recycling stream, and it's not acceptable as a feedstock for biochar. So we don't want that paint carrying on through, even if it's destroyed. We don't want any old lead paint and so on carrying through and causing emission problems. There's been a lot of debate and discussion about polycyclic aromatic hydrocarbons, potential pollutant. Generally in biochars, the PAH, as it's called, quantities and contents are lower than background soil levels. It's degraded fairly quickly in the soil. It's kind of a red herring. You'll see a lot of discussion on the web about PAHs. In practice, we find that, especially with gasification chars and so on, the levels are relatively low. So we haven't seen toxicity issues, heavy metals and so on get tied up permanently by the biochars. So in the leachate tests and so on, we see very, very low levels. You do the toxic leachate characteristic TCLP tests on all these materials, and biochars generally score pretty well. I don't know what experience, Chuck and Mark, you've had with concern about pollutants in biochars. It's more a problem of dust. Unless you wet the biochar, it can be very dusty, and that has its own problems.
Yes. Go ahead, Mark.
Oh, go ahead.
No, with the dust is the big thing, whether in production or even using it. As it's dusty, particularly out in the field along highways, you got to manage it. Definitely wear a mask, because there is still some fine particles. You apply it low to the ground, moisten it before working with it. There's a variety of things to do in how you handle it to minimize both public safety as well as installer safety. If it's and most of the stuff is not pelletized or in bound together in some way to avoid the dust. As far as pollutants, I mean, I guess it just depends on the type of waste you're dealing with and how you're going to use it. If you're using it as a waste disposal system, then of course there's cost savings in that front. But again, as I mentioned earlier, just because it can be carbonized and reduce the waste stream doesn't mean it has a use in your particular application. So just know before you leap on that.
All right, thank you. I do have a couple of questions for specific presenters. So Tom, you had mentioned that biochar can be used as an additive for construction materials. The question is, has any research been done on biochar to replace carbon black as a master batch color for plastic or for use in black rubber applications?
There is actually the USDA Agricultural Research Service in Illinois has been doing a lot of work on carbon black. One of the challenges is to replace carbon black, you need a very high purity carbon. So you need 95% carbon or better. And that's a tough thing to do with most of our biomass materials. If the biomass is that clean, it's probably got a higher value use as solid wood, as whether it's wood pellets or in a engineered wood product or whatever, and it's not going to find its way into the biochar supply stream. So that's really the challenge is the cost. You wind up with a very low yield, making a very high specialty product. Having said that, there are biochars that are being used as colorants in things like feed products and so on. They're basically made into fine particles. And more we're seeing that carbon nanoparticles are important and foliar sprays for plant growth and those kinds of applications. So we're finding that there are high value uses that are not necessarily substitutes for carbon black or even activated carbon.
Great answer. Thank you very much. So it looks like we have about 9 minutes left here. I do have a few questions yet. So here's the specific question for Mark. And Mark, and I'm reading this right as the questioner typed it to me. Wouldn't the strict limitations of high carbon content greater than 60%, preferably greater than 80%, low ash content less than 20%, and a pH less than 7 or 8, severely limit the use of agricultural, particularly manure feedstocks available for biochar production?
Yeah, sure. And it's a great question. And I want to clarify that in the presentation, when I mentioned those specs, I'm talking about the finished biochar. I'm not talking about the raw ingredient when you test it for carbon content or anything else. I'm talking about the finished biochar itself. And those specs are very related to landscape use application for urban soil situations. There's a lot of variety, as we've been talking about, with qualities of biochar, and certainly there are very appropriate uses for biochars that are produced with a carbon content of less than 60. There certainly is a very good use for it. It just may not necessarily be in the landscape world.
Yeah, and let me weigh in on that. The origin of that 60% standard was a regulator looking to control you wanted a metric of some kind. We actually, in the definition that we presented to the organization AFCO, which is an organization that is intended to harmonize soil standards, fertilizer standards across, in North America, all the provinces in Canada and the US, we presented the International Biochar Initiative categorization, which is 30% carbon or more, 10% carbon or more, 30% carbon or more, 60% carbon or more. In that 10 to 30 class, you wind up getting the biosolids. In the 30 to 50%, you get straws, manures, and the 60 plus, you typically get the woods. And as Mark pointed out, these chars have different qualities, and you're not necessarily limited to the 60%, but if a product is sold with a biochar label on it, in 38 states, typically you'll need to have 60% carbon. You can still buy the other product, which people typically call biocarbon.
Fantastic. So we have a few more questions here, and we're going to call this the lightning round here. How does the use of biochar impact the erodibility of soil?
I mean, I would say that biochar is going to help increase soil structure over time through the methods we talked about. So it's going to reduce your erosion when it's incorporated properly into a soil landscape. It should be reduced. Even with the increased infiltration rates, you're not having erosion as a result. It really does help build soil structure, which is the exact opposite of erosion.
Thank you.
I would say in combination with the addition of vegetation, because I have had situations where I can't get the vegetation to establish quickly enough, and you will get some surface erosion, but it's not significant. So any erosion sediment control or stabilization is necessary.
All right, next question. Has the EPA weighed in on the scoring use of biochar for specific TMDLs?
I know that EPA Region 3 has in the past been a supporter of it, and actually was a sponsor of the Biochar 2018 conference. There's other EPA regions, I guess it's EPA Region 3 out west, has been a supporter. I mean, honestly, it has not been EPA that's been the problem with getting biochar usage in stormwater. It has really been the state and local regulators that have been more of the challenge.
Okay, that's good to know. Has there been any assessment, has any assessment been done on greenhouse gas reduction potential in the ag applications like you guys have discussed? Is there any sort of sequestration effect to be recognized?
Yeah, there's both greenhouse gas reduction and sequestration. There's lots and lots of research on that. We're seeing about 3,000 peer-reviewed articles each year. We've got about 16,000 or 17,000 peer-reviewed articles in the last 10 years. About half of those are ag-related, about half of them are environmental. Lots of information on greenhouse gas reduction and carbon sequestration. And in fact, we're participating with the Natural Resource Conservation Service on their new soil carbon amendment, which is a cost share program for adding biochar and compost to agricultural soils, precisely for carbon sequestration, increase the carbon content, and improve sequestration and reduce greenhouse gases.
Fantastic. Okay, two more questions. This one is kind of a general question. Can one of you all describe briefly why it works the way it does? Does it do so from more of a chemical basis, or is it more of a creating a structure like we saw on the slides that other materials can fit in and perform, you know, their remediation task? Is it more of a physical thing, a chemical thing, combination of both? How would you characterize that?
All of the above.
Yeah, all of the above?
Yeah. Yes. It just depends on how it started, if you're proposing it to be used. I mean, Mark enhances his products for specific uses, for specific quality plants. When I go to do soil or even bioretention mixes, I don't, you know, I may add a little bit of compost, but because I'm dealing with nutrients, I try to minimize that. You do need to charge it or allow nature some time to charge the biochar. But initially, the biochar is an amendment, and it basically provides the host for the nutrients and or for the bacteria or microbes. Over time, biochar becomes more part of the soil structure through soil aggregation. So it's a transitional product. It's, you know, that you put in the soil, and over time it actually just becomes part of the soil matrix due to natural processes. So
what they're finding is that it actually reduces the amount of energy required for the microbes to convert nutrients and so on in the biological process. So it is an active battery, if you will. It's an active component of the soil, but even when it's a very, very small percentage.
And also at the international conference in 2018 that was held in Wilmington, the University of Delaware went over some of that, how it works,
right.
In extensive research showing that the wetting and drying cycle of the biochar on a microscopic level is causing the oxidation redox potential. So yeah, it's all of those things, and biochar does have these amazing ability to transform nutrients in soils.
Sounds good. And one last question. Is hydrochar, which is the solid product of the hydrothermal carbonization reaction, is hydrochar on any of your radars as something to look at in the future?
Well, it's still in development. There's quite a lot of research. There's some pilot testing. There's no commercial production in the United States. It's a different product. It's an interesting plant food, if you will. But it's not necessarily a source of recalcitrant carbon from a carbon sequestration point of view. And so it's still, I would call it work in progress.
Sounds good. Well, that is perfect timing. It is now 2:45. So I want to thank Chuck, Tom, and Mark for their time. I want to thank all of the attendees for spending some of your time listening to this information. And again, this webinar, like all the webinars in this series, have been recorded and will be available via YouTube on both the National Recycling Coalition and Recycling Market Center websites. Thank you again for joining us. We hope you will join next month's webinar. Please visit the NRC and RMC websites for scheduled updates.